In this video, we're going to add two more trig functions to our library of graphs. We're going to look at the graphs of both secant of theta and also cosecant of theta. Okay, so let's think for just a second. Secant, if you'll remember, is the reciprocal of cosine. So I have for us here the quadrantal angles, 0, pi over 2, pi, and 3 pi over 2. And we're going to look at what happens with secant in those four places. So first of all, let's go back to cosine because secant and cosine are reciprocals. And cosine, which coordinate does cosine go with? Does cosine go with the x coordinate or does cosine go with the y coordinate? Cosine goes with the x coordinate. So when we look at our points as we go around the unit circle, I'm just going to write the x value of our points. So this one right here, you can see I went 1 unit to the right because the length of the radius of the unit circle is 1. All right, right here, I didn't go left or right at all, so the x value is 0. Here, I went 1 unit to the left, so the x value is -1. And here, I went no units to the right or the left, I only went down, so the x value is 0. Okay, so let's come over here and let's substitute those in. So the secant of 0. Well, secant is the reciprocal of cosine. Reciprocal, you means 1 over something. And the cosine of 0, right here, that coordinate was 1. So I have 1 over 1, which equals 1. So the secant of 0 is 1, exactly like the cosine of 0 is 1, because 1 is its own reciprocal. It doesn't change when you take the reciprocal. Okay, let's move around here to pi over 2. Well, secant of pi over 2 is equal to 1 over cosine of pi over 2. And I can see from my coordinate there that the cosine of pi over 2 is 0. Well, 1 over 0, anytime I have 0 in the denominator, if I'm dividing anything other than 0 itself, anything over 0 is undefined. Okay, so what does that really mean? We write that a lot of times, but what does that mean? What that means is that the graph of secant cannot exist at the value pi over 2 because if I try to divide anything other than 0 by 0, I get something that doesn't work. I'll just get an error. So anytime I'm at pi over 2, the graph ceases to exist. It just stops for a minute, and then it starts over once I pass pi over 2. And we're going to look at the graph as to what feature happens when the graph stops existing at that particular point. All right, let's move around over here to pi. So secant of pi, that's 1 over the cosine of pi. And I can see that the x value of my coordinate there is -1. 1 divided by -1. Well, positive divided by negative is a negative. 1 divided by 1 is 1. So the secant of pi, just like the cosine of pi, is -1. They're going to match both at 0 and at pi. All right, and let's move around to 3 pi over 2. So just like at pi over 2, it's going to be a value of 0 for cosine, and 1 over 0 is undefined. Okay, that gives me something that's undefined. So again, I'm going to have a graphical feature at pi over 2 and also 3 pi over 2 that tells me that the graph of secant does not exist at those particular points. Okay, so let's look at what this graph is going to look like. So you can see I have dotted in here the graph of cosine. I've used those values off of the unit circle. Here's 1, 0, -1, 0, and if we went back to 2 pi, it would go back to 1 again. And let's look at how these relate to what happens with the graph of secant itself. Well, we said that when cosine equals 1, or cosine equals -1, that secant matches that same value because 1 and -1 are both their own reciprocal. So right here, the graphs of secant and cosecant are going to be the same. Same right here at pi, same at 2 pi. And the same will be true if I move into the negative quadrant, that the graphs will be the same at those points because whether you're on the positive half of the x-axis or the negative half of the x-axis, the reciprocal of 1 and -1 are themselves. The reciprocal of 1 is 1, the reciprocal of -1 is -1. Okay, so now let's take care of those undefined values. So anytime I have a something over 2, if my something is odd right here, like 1 or 3, I'm going to get undefined. Okay, so think about what that means for a graph. Is there any way that we could cancel out this 0? Is there anything I can do to make this go away? Well, no. Cosine of pi over 2 is just 0, and there's nothing that it'll cancel with on top. There's just a 1 there. I can't get rid of it by dividing it away. So what's going to happen is I'm going to get an asymptote there. And remember we talked about in the exponential video that an asymptote is a line that the graph gets very, 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 very close to, but it never actually reaches. And what's going to happen is that everyone that's something pi over 2, where that something is an odd number, I'm going to have these asymptotes. So the graph is going to get very, very, very close to these lines, but it's never going to touch them. It's never going to cross them. It's like stuck in between there. Okay, now think about what a reciprocal does. If secant is the reciprocal of cosine, a reciprocal flips something upside down, right? The reciprocal of 3 is 1/3. The reciprocal of 1/4 is 4. It flips it upside down. So the same thing is going to happen with our graph. If you look, you can see I've got like a bowl shape right here. It's an upside down bowl. So when I graph the reciprocal, when I flip all of those values upside down, what I'm going to be left with is a huge right side up bowl. And it's going to go on and on forever, getting closer and closer to this asymptote, on and on forever, getting closer and closer to this asymptote. And the same thing will be true forever and ever to the right and forever and ever to the left. Every time I have one of these upside down bowls, it's going to turn into a right side up bowl, and it's going to go towards that asymptote. It's going to head to infinity on every side of that asymptote for these upside down bowls. Okay, now let's look at the right side up bowls right here. So it's still going to touch right here at negative pi or right here at positive pi. But if I take the reciprocal of this, if I flip this upside down, you can see that I'm going to get an upside down bowl. And the same thing here, I'm going to get an upside down bowl, and it's going to be approaching the asymptote on both sides, but it can't cross over and it can't touch. It's stuck in between there. So it's going to be going toward negative infinity for all of these. So all the ones that are shaped this way, like a hill or like an upside down bowl, they're going to flip this way. And all the ones that are shaped this way, like a valley or like a right side up bowl, they're going to flip this way. And so as we graph secant and cosecant, will work similar to this as well. As we graph those, it's a good idea to look at the one that we've already learned, in this case cosine, and then just flip it upside down in between the asymptotes. Everywhere that cosine is equal to 0, the reciprocal of 0 is undefined. So everywhere that cosine crosses the x-axis, I'm going to have an asymptote as I move my way around. Okay, so let's look at some key features of this. Let's look at the domain. So here I have secant graph for us without cosine and without the asymptotes. This is off of Desmos, just a picture of secant. So the domain. Well, the domain is all the possible x values from left to right. And as you can see, it goes on and on forever, except that it has to stop everywhere there's an asymptote. So it stops here, it stops here, it stops here, it stops here, and it'll keep going on that pattern on and on forever to the right and the left. So the domain turns out to be all possible real numbers except all the places where we have the asymptotes. So look at those. I have something pi over 2 every time, and that something in the numerator is an odd number, 1 or 3. It's going to happen again at 5 and 7. So I'm going to say the domain is all real numbers except n pi over 2, where n is odd. Because like 2 pi over 2, that would simplify to be pi. 4 pi over 2, that would simplify to be 2 pi. And you can see that I do not have asymptotes at those places. I only have asymptotes if the n value that's on there is odd. Okay, so how about range? Let's see what we're going to get for range. Range is all the possible y values. Well, we said that this one goes on and on forever, And this one goes on and on forever. So if I look at the range as being bottom to top, I'm going to go until I get to right here, and then all of a sudden it's going to jump, and it's going to start over again here and go up to infinity. So my range, it's going to start at negative infinity, the smallest possible y value, and it's going to stop right here at -1, including -1, because we could actually put a dot there. And it's going to start over again at +1 and go up to infinity. Both -1 and +1 are included. Okay, so let's look at the x and the y intercepts. Well, this one never crosses the x-axis at all, so this is going to be none. And the y, it's going to cross right here. So that y value is the point 0, 1. It's going to cross the y-axis right here at 1. Okay, let's do something similar with cosecant. We're going to do this one a little bit more quickly because we already talked about the other one. So if I look at the values around the unit circle, remember cosecant goes with sine. So I'm going to look at those y values, 0, 1, 0, and -1. All right, so if I put in 0 right here, 1 over 0, that's going to be undefined. I'm just going to abbreviate because I don't have a lot of space. So you're going to see an asymptote here. 1 over 1 is 1, so the graphs are going to match here. Moving around to pi, I'm going to get 1 over 0, which is undefined, so I'm going to have an asymptote again. And then at 3 pi over 2, that's going to be 1 over -1, which is -1. So they're going to match at that point as well. Okay, so if I have the graph of sine here, and remember, everywhere that sine was equal to 1 or -1, cosecant is going to match. And everywhere that sine is equal to 0, everywhere it crosses the x-axis, I'm going to have an asymptote. So it's very similar to what we saw with secant. And then the bowls are going to flip upside down, or the valleys and the hills are going to flip upside down, just like we had before. It's just that they're not in the same places. Remember how we said secant and sine and cosine are the same graph, just shifted a little bit. So the same is going to be true for secant and cosecant. They're the same graph, they're just shifted pi over 2 radians to the side. So here's what the graph of cosecant is going to look like. It's going to have those asymptotes, it's going to have those points where they connect, and it's going to have those flipped upside down bowls going towards -infinity or +infinity, depending on which side we're on. Okay, so let's look at domain and range, just like we did before. Well, domain, I've got the same thing. It goes on and on forever from left to right, so all real numbers, except I've got all those asymptotes I have to take away. Well, this time, look, this time the asymptotes are here. They've shifted over. So it's all real numbers except n pi, no over 2 this time, n pi, where n is an integer. And any integer will work, right? See here I've got an odd integer, 1 pi. Here I've got an even integer of 2 pi. So as long as n is an integer, n pi are where all the asymptotes are going to be, and we need to throw those out of the domain. Now let's talk about range. So the range is going to be just like secant because they're just the same thing shifted over, right? So remember, I'm going to -infinity here. I'm going to +infinity here. So the range will be -infinity to -1 included because they touch right there. And then I'm going to union that with +1 to +infinity, including 1 as well because they touch in that point. All right, how about x and y intercepts? Let's see what we have here. Well, I never cross the x-axis. That's not part of the range there. So I don't have an x-intercept. So I'm going to write none. And y-intercept, well, this time I have an asymptote because that's 0 pi. 0 is an integer, right? So that's one of my asymptotes. So I do not have any y-intercepts either. I don't have x or y-intercepts for cosecant.